Hello, it's Nick and I am back with a physics video on kinematics, doing a past paper question just so you can get a general understanding of the concept and projectile motion in general. So in this question we have a water droplet leaving the end of a pipe at a height h, and it lands at point Q, which is 3.5 meters horizontally from where it started. The first question is to explain briefly why the horizontal component of the velocity of a droplet of water remains constant as it moves from P to Q. Before we attempt this question, I would like to show you a representation of projectile motion in the air considering air resistance to be negligible. This is our projectile launched with an initial velocity u. As it is launched, this shows its general motion due to factors. To begin with, let's split this velocity into its components. Now, assuming, as said in the question, that the air resistance is negligible over here, we can say that the horizontal velocity does not change. It does not change because there is no force to accelerate or decelerate it. So there is no change horizontally, but vertically, as you can see, it is launched with the initial velocity, giving it a lot of upward component, which slowly decreases, becoming zero at its peak and then acting downwards. This is due to gravity, the acceleration due to gravity. With this knowledge in mind, we can say that here there is no vertical velocity, and because the gravity is not yet acted, and since this horizontal doesn't change, we can say that as it moves, the vertical velocity gradually increases before landing. Now, with this knowledge, we can attempt the question. Explain briefly why the horizontal component blah 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 of the I'm just kidding. Do not say blah 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 to any question. Read it properly. Of the velocity of a droplet remains because there is no force. So we write because there is no horizontal force acting on droplet P. Moving on. Show that the time taken for the droplet of water to move from P to Q is 0.53 seconds. We have our vertical speed, we have our vertical distance, so we just apply the formula speed equals distance by time. Our speed, which is 6.6, equals our distance 3.5 by time. Rearranging that gives you time, which we need to find, equals 3.5 divided by 6.6 meters per second, and you are left with the time equaling 0.53 seconds. Moving on. Calculate height h. This is where our equations come to play. Now, because the height is the displacement, first off, how do we know that the height is the displacement? The displacement between any 2 points is the shortest path to them. If we extend P above Q, it is clear that this is the shortest point between them. Therefore, meaning that is the vertical displacement. The horizontal, the overall displacement is another topic. In general. This is the horizontal displacement. So, just going ahead, the displacement would be, the magnitude of the overall displacement would be the hypotenuse. Anyway, going back to the question at hand. Since now we know that the displacement is the height, we can put that into a formula. So, we'll be using this because we know time and we know acceleration and we know the initial velocity. Although many formulas can be used and derived from these two main formulas. Okay, So the displacement vertically, remember, if we want to find the vertical displacement, our velocity needs to be in vertical component, our acceleration needs to be the acceleration vertically, and so on. We cannot use a horizontal value to find a vertical displacement. Moving on. Now, as I explained earlier, the initial vertical velocity is 0. So this whole segment, which is 0 into 0.53, our time value, which we found over here, is neglected. So the answer to this displacement vertically would equal half into acceleration due to gravity. Now assuming this is our positive direction for gravity, and for velocity, acceleration and vertical component act in this direction. So we take the acceleration as positive, 9.81. It is very important that you add the 1 into 0.53. Do not say into 9.8. You might get a wrong answer, which you will need to round off later, which you may need to round off based on the significant figure required. So we'll do 0.5 into 9.81 into 0.53. Oops, I made a mistake. T is squared. So 0.5 into 9.81 into 0.53 squared, which gives us a value of 1.37. We need to present that in two significant figures. I will present my answer in two significant figures. So I will say 1.4 meters. All right, moving on. For the movement of a droplet of water from P to Q, state and explain whether the displacement of the droplet is less than, more than, or the same distance along its path. What's the distance along its path? The distance along its path is this line, right? This is its motion. But what is its displacement? Remember what I said earlier. Displacement is the shortest route from initial and final position. This would be the, oops, I'm not that good at drawing lines. Oh, this is pretty fancy. It has a scale and all. Okay, let's use this scale. Anyway, I hope you understand what I'm trying to say. This is the displacement. Oof, cannot turn this. Anyway, you get what I'm saying, right? This is our displacement. And by looking at the curve compared to our displacement, the displacement is less than, you can tell by looking, displacement is less than the distance along the path, right? You can tell by looking, this is a curve on the same thing. It's obviously longer. So that's our answer. Now, calculate the magnitude of the displacement of a droplet of water that moves from P to Q. If you want to pause and attempt this question yourself, you can. I will be answering it in 3, 2, 1. Okay, so they want the magnitude of the displacement, right? We found the displacement height. Don't forget, displacement and height are the same in this scenario, to be 1.4 meters. And that's the vertical displacement. We found the horizontal displacement to be 3.5 meters. They want the overall displacement. That would just be the hypotenuse of this right angle triangle. So we can say 1.4 squared plus 3.5 squared equals displacement squared. So let me plug that in. 1.4 squared plus 3.5 squared, and square root of that, which would give us an answer of 3.8 meters. So that is our answer, 3.8 meters. Two significant figures, because this the initial meter presenting was in two significant figures. All right, that is my kinematics section done. I hope you liked it. Physics is super fun. Every question is fun. You need to approach it with a mind that can solve problems and with a mind that's like, whoa, a challenge? I want to do that. Anyway, I hope you enjoyed, and I'll see you in the next one.